Okay. So good morning, everyone. So I'm Jammy from Linaro. Today I would like to have some discussion with you about deep learning on ARM platform. So I will focus on the platform support for deep learning. Since this session only have 25 minutes, so I will go through the slide first, and then we can answer some questions if you have some questions. And otherwise we can talk about it offline. So the presentation will be divided into mainly three parts. So first of all, I will give some brief introduction about deep learning. And secondly, I will talk about the deep learning platform, including the heterogeneous accelerators and the software support. At last, let's have some discussion about the gaps and the challenges to support deep learning on ARM platforms. Okay, so I think deep learning is a very hot topic recently, with applications in areas such as smart audio, computer vision, automotive, robots. So basically, there are three major elements for deep learning. The first one is the advanced neural network algorithms and related models. For example, the convolutional network, the recurrent network, and the long short-term memory support. And there are also some derivative of these algorithms. For example, the region-based convolutional network. And there are also a lot of models developed in the last years. For example, the AlexNet, the VGG, and the GoogleNet from the image recognition, large-scale competition. Right. So, and for the second element, it is more and more powerful computing platforms. Right. So I think this is a major topic for my session today. So and we can have more discussion later about this platform part. The third one is large dataset availability. Right. So there are a lot of datasets available for training of deep learning. For example, the ImageNet for image recognition, right, and the SFO17, SFO100, right. So an audio set for audio support, ActivityNet for behavior recognition. Okay, so these are three major basic elements of deep learning. So for deep learning, there are mainly two stages, training and inference. So the deep learning training is mainly done on cloud and dataset side because it needs very powerful computing capability. Otherwise, the training will last a very long time to complete. So different deep learning frameworks can be selected for the training in cloud side. Right, so to generate trained model from the data set, right? So and to get the weights, right, for the model. While the inference can be done either on cloud data center or on edge devices. Right? So for the inference on edge devices, I think the pre-trained model can be loaded to do the immediate prediction with low latency and privacy. I think there is some trend to have more inference support on edge devices. I think this is a good opportunity for our platforms. Okay, so next, let's have some look at the platform part to support deep learning. So here is a diagram trying to describe the architecture part. So hardware support, right? There are different hardware accelerators which can be used to accelerate deep learning operations. And the drivers to support those hardwares, right, including the kernel level driver, the user space runtime. Then on top of that, there are some low-level libraries for deep learning operations. For example, the basic linear algebra library, right? So for the Fourier transformation support, and usually the hardware vendors have their own version of these low-level libraries with their own optimization and customization. And there are some popular API support in this level as well. For example, the NVIDIA CUDA, right? And other, for example, OpenCL support, right? So moving up, so there are a lot of deep learning frameworks used in the world now. So I just listed some most popular one here, right? For example, the Cafe, the TensorFlow from Google, Cafe 2 from Facebook, right? And NextNet, Torch, and CNTK from Microsoft, right? So, and moving up, based on these frameworks, application can be developed for deep learning support, right? In different areas. So, I think from a framework part, we can, because there are a lot of framework support now, there is some kind of fragmentation, right? So, for example, for application developers, how they can switch between different frameworks, how they can make their application portable across different frameworks, right? To use different models. And for each framework, how they can use different accelerators, right? So there are a lot of problems here, I think, and hope we can address them in the future. And I think the bigger players in this area have already realized some problems for this ecosystem, and they have some solutions to address some of them. But I think there are still some things we can improve. Okay. So I summarized some heterogeneous accelerators here. So GPU, FPGA, ASIC, DSP, and there are some others. For example, the neuromorphic processors are not listed here. So for GPU part, I think NVIDIA is dominating the market now. They have very good product portfolio, right? For example, in data center side, they have very good Tesla products. And for automotive, they have a Jammy PX platform. And they also have some embedded products for computer vision, right, support. And AMD is also promoting some machine learning products called Regency. And they also established some collaboration with Baidu from China for deep learning optimizations. So they are trying to catch up, but it is still a long way to go. There are also some mobile GPUs mostly used on ARM products, right? So Mali, Qualcomm, Arduino, Imagination Power VR, various Silicon Bounty, right? So there are several mobile GPUs. I think the mobile GPU is mainly for inference support. It is not suitable for training. So for ASIC part, I think the most popular is Google GPU. So the first generation of GPU can only be used for inference. But this year, Google announced GPU2, which can also be used for training support. Intel also bought Nirvana for some ASIC support in this area. NVIDIA has DLA, which is mainly used for automotive now. For Drive PX2, the DLA is integrated. And they also recently open sourced this DLA implementation. So and there are also some players in China, for example, Horizon Robotics and Cambrican with their ASIC for deep learning. Right? So I think the Cambrican MPU is also integrated by the latest Kirin 970 from HiSilicon. Okay, so from FPGA part, I think there are two big players in the market. There are Altera, which is now part of Intel. They have Stratex, Arena, Cyclone, series FPGA. Xilinx, they have Astro Plus. So, and there are some other Xilinx-based products in China. For example, the the DQ from DP Tech. So, and Baidu is also working on some Xilinx-based products called XPU. So yeah, there are a lot of PU now in the markets. So and for edge devices, I think DSP can also be leveraged. Right? So there are a lot of also there are several implementations in the markets. Right? So for example, Qualcomm Hexagon, which is also supported by their neural processing engine. Right? So there is also some products from CEVA. Right? So they have the XM series, and some products from TI. Right? Okay, so we can see that there are a lot of options for hardware acceleration, but you can leverage for deep learning. But how we can use them, this is a big problem, I think. Okay, so let's have a look at some interface and libraries for deep learning. So I think the most popular one is NVIDIA CUDA, because there are a lot of products now in the market using CUDA. So, but CUDA is a proprietary implementation from NVIDIA, and it can also be only be used on NVIDIA products. Other vendors cannot use it. For the AMD HIP is the heterogeneous compute interface for portability. So this HIP interface is actually some maybe similar to support both AMD heterogeneous compute compiler and NVIDIA NV compiler, right? To make the porting of CUDA application to AMD platform easy. There are also several standards or interfaces defined by the Cronus organization. For example, OpenCL, it is the open computing language. So OpenCL can support not only GPU, but also FPGA, DSP, and other accelerators. And OpenVX is mainly for image processing and computer vision. And there is also some specific extension for neural network. And another one is Vulkan. So Vulkan is designed for both graphics and compute, but it is mainly used for graphics now, as I can say. So I think I'm not quite sure the plan for computer support with Vulkan from the vendors. So this is some native interfaces, and there are some libraries accordingly to use these interfaces. For example, NVIDIA, they have a CUDA DNN library, and CUDA Plus, CUDA Sparse using the CUDA APIs. And AMD also has related libraries with using their HIP interfaces and the underlying local platform. And they have the MI Open, Machine Intelligence Open Library for the optimization to run on AMD platforms. So OpenCL, there are also some libraries. For example, ARM Computer Library has OpenCL support. which requires on some also requires on some OpenCL extensions, for example, the non-uniform workgroup size support. This is also enabled by default in OpenCL 2.0, but it is needed for some OpenCL 1.1 or 1.2 implementations. And the Qualcomm also has the neural processing engine. The neural processing engine can use all the processes on Qualcomm platform, including CPU, GPU, DSP. So for GPU part, OpenCL is also used, as I know. So there are also some other libraries, like Aging, which is a C++ temporary library for linear algebra, and OpenBLAS, neural network pack, etc. So and there is also some popular libraries, for example, OpenCV, right, open source computer vision library. And several months ago, OpenCV also announced one DNN module specifically for deep learning. So and this module is based on the highly intermediate representation. So yeah, so we can talk more about the highly intermediate representation later. So it is very good. So and from other vendors, for example, from Xilinx side, they have their own DNN and GNN libraries. So there are similar libraries from other vendors, so I cannot list all of them here. So there are a lot of implementations, from the vendors. Okay, so the frameworks. So this is a big part, I think. Okay. So I will try to be bigger. So we can see that CUDA is supported by all the frameworks I listed here, and there's some support, auto-execute support by HIP, and for OpenCL, and ACL has some auto-execute support of Café and MXNet. Right, so NP also has some support for Café 2, TensorFlow, and etc. So, for the benchmark testing, I think there are some good initiatives from the community. For example, they're called Collective Knowledge SDK for Artificial Intelligence. This is good infrastructure to automate benchmarking, optimization, co-design the whole deep learning stack to satisfy different requirements. And it defines some unified JSON APIs to abstract access to changing software and hardware. So, and Baidu also open source their DeepBench benchmark to benchmark some basic level operations on different hardwares for deep learning. Okay, so let's have a look at the gaps and challenges. So first, I will talk about some architecture agnostic issues. So we can see that there are a lot of vendor-specific APIs for heterogeneous accelerators. Right? So for NVIDIA CUDA and HIP. For Google TPU, they have their stream execute API. Right? So I think to make the ecosystem better, we should have some unified API, or not so much API, especially for application developers, framework developers, right? I'm not quite sure if OpenCL can take this, but I cannot see some other good option here. So yeah, but the problem here is that OpenCL support is limited so far by the deep learning frameworks. But the situation is changing with some architectural changes in the popular frameworks. So for OpenCL support, there is no official enablement by default for almost all the major deep learning frameworks. And there are some research projects to run CUDA on OpenCL called Coriander. you can see here. So the CUDA kernel can be compiled to some intermediate byte code, right? So for the host code, they can be translated to host byte code, and for the CUDA kernel, that can be translated to the device byte code. And the compilation is done by Clan, right? So at runtime, the device byte code is translated to OpenCL kernel, right? So and the CUDA cores are translated to OpenCL cores. In this case, the previous CUDA implementations can run on platforms with only OpenCL support. Yeah, so I have a link here about this Crescendo design and the part. So if you have interest, you can have a look at it. So another big issue here is the fragmentation of deep learning frameworks. Right, so yeah, for each bigger player, they have their own deep learning framework, right? So, and for each framework, it is not easier to add new accelerator support. And if you add the accelerator support for one framework, after you switch to another framework, you need to do it again. So quite a bunch of duplicated effort here. So some unified computational graph intermediate representation and tense intermediate representation support can probably be helpful to have some unified implementation. I will talk more about it the intermediate representation later. And for different deep learning frameworks, there is no good interoperability. The community already realized some problems. For example, to share the operator and the tensor between different frameworks. So there is some deep learning pack proposal under discussion, which will be adopted by MXNet, PyTorch, K2, and TinyDNN. And also there are some model translation required to support different field frameworks. So with regard to applications, usually we need some unified APIs for portability and flexibility. So Keras is a Python deep learning library supporting TensorFlow, CNTK, CNO, and MXN now. So you can just use this Keras library and then configure it to use different deep learning framework. For Google, they announced TensorFlow Lite this year. So and they have their neural network API defined. So from the announcement killing 970 from Hyatt, the neural network API is used. I don't know. So here there are some implementation of the intermediate representation. So for example, the Google XLA, which is a domain-specific compiler to support different backends. For example, if you can add the backend here for, I think the major focus from Google is to make it easier to add a new device support. For example, they want to add the TPU support. Previously, it is difficult to support a TPU, but with this XLA support, the hardware part is abstracted, so it can be easier. Right. So and for other frameworks, they have a similar implementation. But we do need a unified one for all the frameworks. Instead of each framework have one abstraction implementation, but they use their own. So it is some kind of new fragmentation in my understanding. So I'm wondering who will become the LLVM for deep learning, right? Because for LLVM, they have a lot of front ends, right? And it can also support a lot of back ends for acceleration. So this is, I think this is the goal we should like to try to achieve. Okay, so let's talk about some ARM-specific challenges here. So for the deep learning training, so because the major implementation solution is based on GPU, right? But for ARM side, there are seldom ARM boards with good PCIe capability, right? Because for example, the AMD GPU, AMD local implementation for deep learning requires a PCIe Gen 3 with PCIe atomic support. Some high-end FPGA card also requires PCIe Gen 3 or Gen 4. And on ARM platforms, the discrete graphics driver support is quite limited. Right? So NVIDIA proprietary driver only supports ARM32. There's no 64-bit support. And AMD local has some support for KVM SunX, but no generic ARM support. And for ARM world, I think at this moment, the binary OpenCL drivers for mobile GPUs cannot be retrieved easily. For example, for the 96 boards, we cannot find the OpenCL driver easily. So I think this is one area we can improve moving forward with our partners. And for ARM, we can also do some optimizations for edge devices. For example, the memory footprint optimization. Google is doing something in this area to make TensorFlow work better on mobile devices. For example, the quantization and the low precision inference support. Previously, the floating point is used for the inference, but now they are trying to use some unitary support for the inference so that the footprint can be reduced. And we also, because the power is very important on edge devices, so we also needed to check about power efficiency with different accelerator solutions. So I listed here some the OpenCL support for 96 boards. And unluckily, I cannot find all the OpenCL drivers for these platforms. And I found one for Bubblegum 96. And we also did some simple testing on Bubblegum 96. And this is forward pass testing with 19 convolutional layers. So we can see that the performance can be, we can have good performance for GPU acceleration for convolutional network, right? So very huge improvement. Okay, so yeah, so hope we can still have several minutes to answer your questions.
You were talking there about the use of GPUs and dedicated ASICs. Is the move to dedicated hardware for deep learning inevitable, or is there ever a chance we'll be able to move back to using general processors with things like the scalable vector extensions?
Yeah, I think there are different advantages to these accelerators, right? So for example, GPU have better floating point support, and it is more general, right? And it has more capability for parallel computing. And for FPGA, it has very good advantage for hardware programmability, right? So, and as I know, there will be some FPGA-based 96 boards, which I think will be very good for the work in this area, right? So, and for ASIC, I think the ASIC part, will also be mainly for two parts. So cloud side, we will have TPU, and in device side, for example, NVIDIA has their DOA, right? And there are some other products which can also be used as devices. Hope we can work with related vendors to create some boards so that the community can use them for investigation and or for making products. Yeah. Okay. Yeah. Okay, so thank you very much. If you have further questions, you can talk with me offline. Thank you.